We'll show you how we can import the step file into 3D CAM and machine the end section. So it's in the XY plane, as you can see. So we need to rotate the model round so that it's in the direction we want it to be. So to do that, we go to Geometry, Rotate, and we'll rotate that round in the YZ plane by 90 degrees. Okay, so that's moved it round, so it's in the correct orientation, X and Y. So now we need to set the 0 position, so we go to Set Origin, and we can have the minimum in X, midpoint in Y, and the maximum in Z. So the part now is there. We can change the origin around as you need to. Okay, so to machine the end section here, we'll just concentrate on the 3D part rather than just the slot, which is easy enough to machine. So what we need to do is to create a sketch which will act as the boundary. So if we go into the XY view and then into Geometry, and I'm just going to draw a rectangle around the shape that we want to machine. If I want to include these angle sections here, then I can just create a rectangle which is bigger than it. If I know the exact sizes, then I can type them in to the sizes of the rectangle here. So that creates a sketch which will be used as the boundary for machining. So to do 3D machining, we need to create a surface from the solid model, and that's a question of just clicking the surface icon here and choosing the tolerance. This is a tolerance based on the cut vectors that will be used, so obviously the smaller the tolerance, the finer the machining, but also the longer processing and the longer G-code file you'll have at the end. So I'm working in millimeters, so 0.1 of a millimeter is normally pretty good. The tools that are defined, I've got a selection of tools here. If I need to use more tools, then I can simply define new tools and keep them in the default library. But I guess something like a 10mm end mill will be okay for this. Okay, so we need to create a pocketing operation based on that sketch. So we highlight the sketch, right click and say a new pocketing operation. We can set the step over, so if this is a roughing operation, we'd probably want quite a large step over, say about 4mm. We don't need a material allowance on there. This will be an allowance in X and Y, but because we're just roughing, we probably don't need that. We'll start at the outside. We'll choose the tool we want to use, which will be a 10mm ball nose end mill. We'll ask it to consider the surface, and then we can give it the start point in Z, the clearance plane, clear of any fixturing, the feed change plane where it changes from rapid to feed rate, the final depth, and the step down. So I'll just leave that as 0 for the time being, just to show you how that calculates the toolpath. So that does a roughing toolpath based on that shape, so that looks pretty good. What we'll do now is we'll change our step down to say something like 4mm, and that's now recalculating, as you see. So the overall size of the model and the coarseness factor that you've chosen will determine the processing speed, also whether you've got a fast processor in your PC as well. So that's produced the roughing toolpath. As you can see there, the steps down in the Z axis. So if we were happy with that, we could then just run the simulator. If I haven't saved the job away, it asks me to save it. Just call it hull. So that's now saved that job file away and is creating the data to pass through to the simulator. And we can leave all the defaults and just click simulate. So using the video controls at the top here, we can adjust the simulation speed. So this is doing zigzag style, but we can also use contour style where it will follow the shape of the outside contour and then get progressively smaller or bigger. So it creates the toolpath and then drapes it on top of the model. Okay, so I'll stop that and then we'll just run that through to the end. So that's the roughing toolpath on there. So if we now go back and we'll create a finishing toolpath. So we'll use that same sketch, create a pocketing operation. This time we'll set the step over to a very fine amount. We're using zigzag machining, but this time I'll go to 90 degrees so it's cutting across the shape rather than along it. We don't need the step down, so I'll change that to 0 and we click OK. So that's now recalculating that surface, but this is a finishing toolpath, so the calculation time will be a wee bit longer. And the other thing that we could do here to speed up the processing would be to make a smaller rectangle for cutting so that it's only considering just this one area here. Okay, so that's created the toolpath. Now if we go into the simulator, and then we'll just run that straight to the end so we can see the end result of that. So that's produced the toolpath for that shape. The only thing that we'd need to do would just be to do a 2D operation just on that slot, and we might also just need to do a profiling operation around the outside just to get the final shape there. When we're in the simulator, we could also look at the complete machine tool rather than just the workpiece and the tool. So now when we run that, it's the machine bed which is moving, and so on. But in most cases just the workpiece focus is the one that you want. If there'd been any, oops, pardon me, just stop that. If there'd been any collisions with the arbor or the chuck or the spindle of the machine, then we'd see that in the report section here. We can also change the accuracy of the model and the accuracy of the visualization. So if I fast forward that, and fast forward to the end, and if I look at that area now and apply a refine to that, okay, so that's doing the refine operation just on that area. Okay, so that's how to create the toolpath. The last thing would be to post-process, and you'd need to choose the post-processor using the setup dialog box here. So that would be the post-processor that is common to all the PartMaster modules. Okay, so that's how you do that.